Now we're going to verify how we got y, our pre-image function y is equal to 1 minus x squared. Now it's not very obvious from the given graph, but treating this in an algebraic way will lead us to graph in this manner. So let's do it. First, to be able to get rid of the square root, we're going to square both sides. Okay, so that gives us y squared is equal to 1 minus x squared. Now you can see that this is primarily, okay, an example of a circle by transposing x squared to the left side. So we will have x squared plus y squared is equal to 1. And obviously this is an equation of a circle. Well, the standard equation of a circle is in this way: x minus h square plus y minus k square is equal to r square, where our center will lie at hk and our radius is given by our r. So in this case, in the example here, in this example, we are actually dealing with a circle with a center of 0, 0, or in other words, is the origin, and then we have a radius which is equal to r squared is equal to 1 squared, so r is equal to 1. But notice that our function y is equal to 1 minus x squared is only concerned on the positive part. How? Now, by putting this again in that form, by solving for y, so x squared plus y squared is equal to 1. When we are going to solve for y, so y squared is equal to 1 minus x squared, and our y will be equal to, it should be positive or negative 1 minus x squared. Now we are very much concerned only on the positive part of our original function for the circle x squared plus y squared is equal to 1. So if we're going to graph this thing here, originally this function here, if we're going to graph it, we have a circle of unit 1. So let's graph. Circle of unit 1, it would be okay, it should be like that. But we are only concerned at the top part, the positive part, so I'm going to highlight this with we are only concerned at the positive part. So it's a semicircle with a radius of 1 still. Okay. Now the pre-image function is actually this a circle. It's a semicircle taken from a circle function, a circular function. Now the image function here that you see is actually g of x is equal to 3 times square root of 1 minus x over 5 square, if we're going to use this standard or our original function square root of 1 minus x squared. Now we came up with this image function. Now let's confirm algebraically if the graph of this function g of x is the same as what we see in this graph here. So let's put y is equal to g of x. Then we're going to get y is equal to 3 square root of 1 minus x over 5 square. Squaring both sides will give us 9 times 1 minus x squared over 25. Dividing this by 9 for both sides, we will get y squared over 9 is equal to 1 minus x squared over 25. Now as you notice, this is an equation of an ellipse with transforming. Okay, we're going to transpose our x to the other side, so we have x squared over 25 plus y squared over 9 would be equal to 1, which is an ellipse. It is an ellipse with a semi-major axis at x is equal to positive and negative 5, and y, the coordinate, okay, of y would be y equals positive negative 3 for the semi-minor axis. Now let's graph that one. We have 2, 3, 4, 5, 2, 3, 4, 5, and the y-axis we have 3, 3. So graphing those, graphing the ellipse, we will get something like this. Should be more curved. Okay, it should be. I messed that up. Okay, it should be like this. Okay, so that's our ellipse. Now we're only concerned again on the positive part here. So we disregard the negative, x to negative. Okay? So we're going to get this graph only. So as you can see, it is very much similar to what we saw in the given figure, okay, depicting the image function and pre-image function. So that is about dilation. Now on the second lecture, we're going to see how translations are made.